Let us move on to our next topic, regioselective reaction. What is regioselectivity? If more than one reaction could occur between a set of reactants under the same conditions giving products that are constitutional isomers, and if one product forms in greater amount than the other, the overall reaction is said to be regioselective. Let us say there are three reactions that could happen between the hypothetical reactants A and B under the same conditions, giving constitutionally isomeric products C, D and E. There are two possibilities. Let us see what are these two possibilities. The three products can form in equal amounts. That is, the total product is 33% in C, another 33% in D, and another 33% in E. The percentage are called relative yield of the product. If this is what observed, then the overall reaction between A and B is not stereoselective. On the other hand, if one product is formed in greater amount than the other, let us say for example, the relative yields of C, D and E are 25, 50 and 25. If this is what is observed, then the overall reaction between A and B is regioselective in nature. And please remember, the product formed are regioisomers. In this reaction, experimentally, 2 is the major product, whereas 3 is the minor product. Thus, the overall reaction between 1 and HBr is regioselective towards 2. Let us take another example. If more than one reaction could occur between a set of reactants under the same conditions giving products that are constitutional isomers, and if only one product is observed, the overall reaction is said to be 100% regioselective or regiospecific. This is very much observed in Markovnikov's addition. The only observed product is 5. The relative yields between 5 and 6 are 100% and 0% respectively. Thus, the overall reaction between 4 and HBr is regiospecific towards 5, and please remember 5 and 6 are regioisomers. Regiospecificity is merely the limiting case of regioselectivity. All regiospecific reactions are regioselective, but not all regioselective reactions are regiospecific. Another point of view. Let us take a non-symmetrical reagent where, let us say, a reagent is of the type A and B, where A is not equal to B, and it is added to an alkene which is non-symmetrical in nature, where the groups at each end of the double bond are different. Then two isomeric products that are constitutional isomers are obtained. For example, the reaction of HCl with propene gives 1-chloropropane and 2-chloropropane. Normally, 2-chloropropane is the major product. Since one product is favored over the other, the reaction is said to be regioselective. If 2-chloropropane is the only product formed, then the reaction is regiospecific. Let us take another example. Any process that favors the bond formation at a particular atom over other possible atom, the description of reactions regioselectivity is called the reactions regiochemistry. In this case, the addition of HBr to 1-methyl cyclohexene is a regioselective reaction because it favors the formation of a bond between a tertiary carbon of an alkene and the bromine atom instead of secondary carbon and the bromine atom. This regioselectivity is the basis for Markovnikov's rule. Let us move on to our next topic, chemoselectivity. What is a chemoselective reaction? If an organic compound has more than one different functional group or more than one like functional groups that are not equivalent, and if a reagent tends to react exclusively or predominantly with one of the functional group, the reaction is said to be chemoselective. For example, both ketones and carboxylic acids can be reduced by alcohols. Let us take a molecule that contains both keto group and a acid group. When this is treated with a reducing agent, three reactions are possible. If only the keto group is reduced, we end up with this product, and if only the carboxylic acid group is reduced, we end up with this product, and if both the groups are reduced, we end up with this product. Now, when one is treated with the reducing agent sodium borohydride, the only organic product observed is 2. Evidently, sodium borohydrate reacts with only one of the two functional groups in the starting material. Thus, the reaction of 1 with sodium borohydride is chemoselective in nature. Let us take another example. Those reactions that operates exclusively on one functional group in the presence of other functional group are called chemoselective reactions. Now in this example, when the reactant is treated with sodium borohydride, only the keto group is reduced and the OH group remains unchanged. The reaction is chemoselective because the ketone is reduced by sodium borohydride but the ester group remains unchanged. On the other hand, when we use lithium aluminum hydride, both the keto group and the ester group are reduced. So, when lithium aluminum hydride is used, the reaction is not chemoselective because both the ketone and ester groups are reduced. Thank you for watching.